Today we will study about integration by parts. In this lesson, we will see what is the formula of the integration by parts and how do we integrate the product of functions using integration by parts. Before we see what is integration by parts, I want to recall the prior knowledge about the integration that you have learned before. If we see from question number 1, find the integral of the following problems. Number 1 is integral of 2x plus 5 to the power of 4 dx. If we remember, the question number 1 is following the form of integral ax plus b to the power of n dx. And this answer is equals to, this is the opposite of the power rule combined with the chain rule. So this is ax plus b to the power of n plus 1. So we add the power by 1 first, and then we divide by the new power, the n plus 1. And then, since this is a combination with the chain rule, so we have to divide by the derivative of ax plus b, which is a plus c, yeah? So the opposite of this form is a combination of the power rule and chain rule, or usually we say it a substitution method, but in a simple way. Yeah, the substitution method, if you remember, if it follows integral of fx times f accent x, the f prime or f accent is referred to the first derivative of fx dx. So the result, this is using substitution method. So the result will be fx here plus c. So we can use fx as u. So the answer for this one is, so we have 2x plus 5 to the power of 4. We add by 1, so it become 5. Now we divide by 5 and divide by the derivative of 2x plus 5, which is equals to 2. Yang ini nggak usah aja kali ya. So now integral of 2x plus 5 to the power of 4 is equals to, so this is 2x plus 5 to the power of 4 plus 1, which is 5. And then we divide by the new power. And then don't forget to divide by the first derivative of 2x plus 5, which is equals to 2 plus c. So this is equals to 1 over 10 to x plus 5 to the power of 5 plus c. The second one, integral of x plus 2 times x to x minus 1 dx. To solve this equation, we can expand the expression first. X plus 2 times 2x minus 1 . We can expand to solve this integration. We can expand the expression first. So it's become 2x squared minus x plus 4x minus 2 dx. Or this is equals to integral of 2x squared plus 3x minus 2 dx. So the result is, this is a normal power integration, yeah, power rule. So this is 2 over 3 x to the power of 3 plus 3 over 2 x squared minus 2x plus c. And how about the third one? The third one, if we see that integral of x times 3x squared minus 2 to the power of 4 dx. If we see that x is the part of the derivative of 3x squared minus 2 to the power of 4. So this is similar to number 1. We can use substitution method. So if we have substitution method, integral of fx times the derivative of fx dx. So we can use fx as u. And then later we will simplify the expression into the power rule. So in this case, so fx will be the f prime x, 3x squared minus 2 will be the fx. Now I can let u equals to 3x squared minus 2. So du will be equals to 6x dx. So in here I can rewrite as x dx will be equals to du over 6. Now we can see here x dx is the part of the derivative of the u in here. So we have x and dx here. This is as the part of the derivative. So I can rewrite this as integral. Okay, I rewrite first 3x squared minus 2 to the power of 4 x dx. So this is integral. This is u to the power of 4 x dx replaced by du over 6. So this is 1 over 6 integral u to the power of 4. This is u, not 4, yeah? Du. Now this is a power rule. So since this is a power rule, we can just integrate using the normal power rule. So 1 over 6 times u to the power of 5, and then divide by 5 plus c. So this is 1 over 30. And the u, we substitute it back into 3x squared minus 2 to the power of 5 plus c. So this is the answer for question number 1, 2, and 3. These 3 example questions are still easy to be integrated. Now let's see number 4. Integral of x cos 2x dx. This question number 4 is similar to question number 2. This is a multiplication. If we see from number 2, question number 2, it is a multiplication. But the difference is, on the question number 2, we can expand the equation to form the power rule. But in this question number 4, we cannot expand because x and cos 2x are not expandable. So that, and then how do we integrate this? If we see x is not the derivative of cos 2x, or vice versa. So we cannot use substitution method in here. So to solve this kind of question, now I introduce you to the new method of integration that called integration by part. Now, integration by part is the inverse of product rule in differentiation, yeah? So if we have normal power rule in differentiation, the opposite, the reverse is, the reverse process is integration by power rule. If we have chain rule in differentiation, the opposite is substitution method. Now, if we have product rule in differentiation, so the opposite process is called integration by parts. So if we see from the equation of the product rule, when we have y equals to uv and the derivative of y is equals to u prime v plus uv prime, while u prime and v prime are the derivative of u and v with respect to variable x. So I can rewrite as du dx v plus u dv dx. And then I try to rearrange the last part, the u dv. I rearrange it. So u dv will be integral of dy dx minus with du dx times v. And then I integrate both sides with respect to x. So everything I integrate with respect to x. So we can simplify into integral u dv equals to integral duv minus integral v du. Now, from here, we can have that integral duv is uv. So from here, we can have the formula of integration by parts. Integral u dv is equals to uv minus integral v du. This is the formula for integration by parts. So one of the equation must be replaced by u, and the other one should be dv. The question, how do you choose which one or which function you should express as u? You can choose, you can follow this method, yeah? I give you the method. This method is called LIATME. If you see, yeah? Okay. So L is logarithm, I is inverse trigonometry, A is algebra, T is trigonometry, and E is exponential. So in logarithm, usually we have ln x. For the exponential, we have e to the power of something. Now, how do you choose u? So which one comes first? You choose as u. Yeah. If you have logarithm and algebra, since L is come first, so you choose the logarithm as u and the other one as dv. So let's see the examples. The first one, integral of x cos x dx. In this case, we have x as algebra and cos x as trigonometry. So according to the rule LIATE, so we see that the algebra is coming first than t. So A is coming before the t. So that means we can use A as u and the rest as dv. So u is x, while dv is cos x dx. Now you derive u into du, so the derivative of x is dx, is 1 dx, yeah? And for the dv, now you do the opposite, you integrate. So dv is integrated into v, and the integration of cos x dx is sin x. No need to put plus c here, we just put it at the end. Yeah. So in integration by parts, u will be derived and dv will be integrated. So now we put into the formula of the integration by part is uv minus integral v du. So uv is u x, see the arrow here, so x times the sine x, so x and x, minus integral v du. So I put in this way so you can see the arrow, the order of the arrow. So v integral v du, so integral sine x dx, yeah, sine x multiplied by dx. So now we have x sine x here, so we just copy it. And then now we have integral sine x dx now to be integrated normally. So integral sine x is negative cos x, so it becomes plus cos x, and then we just add plus c here. So this is the final answer of the result of the integral of x cos x dx. Let's see question number 2. X sine x dx. So this is similar, yeah? X is algebra, sine x is trigonometry. Since a comes before t, so we use u as x, and then sine x ds as dv. dv is sine x dx. So derive u, du equals to dx, and then integrate v, negative sine x dx become negative cos x when we integrate. Now we put in the formula again. So uv, u times v. So x minus cos x minus integral v du. So integral v du. We multiply. So now we have negative x cos x. And then this is become positive integral cos x dx. Now, what is the integral cos x dx? It's sine x plus c. So this is the final answer. Let's see the other examples. Number 3. Now we have x and e to the power of 2x dx. Okay, let us identify. Well, x is an algebra, e is an exponential. Again, LIATE. So a comes before e. So a will be x will be u, and e will be dv. So u is x, du is dx, and dv is e to x dx. The integration of e to x is e to x, and divide by the derivative of 2x, which is 2. Now we put again into the formula uv minus integral v du. So uv x times half e to x minus integral half e to x times dx. So this one. So this one we copy. And then integral of half e to x dx is again, it's still e to x, but now divide by 2 again, so it becomes 1 over 4 plus c. Do you find it quite easy? Because you just put it into the formula, you find the u and dv, and then put it into the formula. 4. X ln x dx. So x again is an algebra. Now ln x is a logarithm. Now since L comes before A, so now the u is ln x. The derivative of ln x du is 1 over x dx. Remember the basic differentiation and integration, yeah? And dv is x dx. So v is, this is a normal power rule. So half x squared. So again, uv minus integral v du. V du. So it's ln x times half x squared minus integral half x squared times 1 over x. Here, yeah? So, okay, the first part, we can just copy it. And for the second part, now we can simplify. X and x squared, yeah? X squared with 1 over x. It's become half x only. Now if we integrate half x, the x become 1/4 x squared plus c. For the first part, usually we just copy it because we only need to integrate the last part, the second part in here. Now, number 5 is the example for the repeated integration by parts. So if we see the question, ex sin x dx. So identify ex is exponent, sine is t. Which one comes first? Yes, t is coming first. T comes before e. So that means the u will be the sine x, and dv will be ex dx. So we have du equals to cos x dx, and v is still ex. Again, uv minus integral v du. So uv minus integral v du. So ex sin x minus integral ex cos x dx. Now, if you see this one, so in this, the last part, we have integral of ex cos x dx, which is we cannot integrate it again using the normal rule. So we have to use another integration by parts. So in here, again, this is e, this is t. So the u will be the cos. So u will be cos x, and du is negative sin x dx. Yeah, and dv is ex dx. V is integral of ex dx is just ex. See, you see in here we use integration by parts in integration by parts. So we use double integration by parts in here. That's why we call it as repeated integration by parts. So now for the first one, as usual, we just copy it. And then to integrate this, we have to apply again the formula. So we prepare the bracket. So uv minus integral v du. So uv cos x times ex here minus integral v du. So negative ex sin x dx. Negative, negative become positive. Here, I just copy here. Everything I copy. Just change the sign. And then I write the question. This is the question. I write it here. Yeah, so this one is the question. Now, since we have another integral at the last part, so the other one we just copy and then open the bracket, so it will the positive sign here become negative sign here, and we still have integral ex sin x dx at the end, which is we cannot integrate anymore. Now, how do we integrate this then? If we notice, integral ex sin x dx is in this part is the same as the question. That's why I can combine it. So it becomes 2 because this is negative one. When I move it to the left, it becomes positive. So that's why it's become 2 integral ex and x dx. So we just copy this and we just copy that. Now since the equation is integral ex dx sin integral ex sin x dx, so we just divide this one by 2. So half ex sin x minus ex cos x, and then we just add plus 2. So this is repeated integral by part. Here are some exercises that you can try. So first we have to identify which one is u. How do you identify? We can use LIATE. Which one comes first? You choose as u. Okay, I think that's all for this lesson. Thank you very much and have a wonderful day. Bye-bye.